Let's take a look at some loops. We'll begin with a while loop. And a while loop counts how many times you go through a loop. And it does while some Boolean expression is true, you'll keep going through the loop. And when that expression is false, you'll stop going through the loop. So let's do a simple count. We'll start with our count equal to 0. And we'll make a Boolean expression. And a Boolean expression, remember, has a value of true or false. So in this case, we'll say while our count is less than 8, we'll print the count. And I'll put a comma after that. That way we'll print all the count values in on the same line. And let's also increase our count each time through the loop. So our count will start at 0, and while that count is less than 8, we'll print, and then when and each time we print, we will add 1 to the count, and when the count is no longer less than 8, that is, it has a value of 9, we will stop. So let's take a look. So you see we get 0, 1, 2, 3, 4, 5, 6, 7. When as soon as the count gets to a value of 8, 8 is no longer, the 8 less than 8 is false, and so our loop ends. So let's actually take an example, and let's write a loop that will keep asking for even numbers until, in fact, you input an even number. So we'll open a new window here to write a program. And as before, we will ask for some input, a number string. Raw input, enter an even number. Call it an integer there, and as before, we have to convert that string. Raw input comes in as a string, so I need to convert it to an integer. Now I have an integer, and we want to check to see whether it's even or not. So, is our number evenly divisible by 2? That is, the remainder when we divide by 2, is that 0? So that would be even. So let's do this so when it's not even, we will keep looping because you did not give me an even number. So if I did not get an even number, I'll print a nasty note. Error, even number wanted. And now I need to ask for that number again and convert it into an integer. So now I'll just keep going around and around until we get an even integer. And once I do, let's print it. The number is even. So we'll go around and around. That check to see whether it's even or not will be, as long as that's false, then we will keep asking again. So let's save this guy. Always remembering to put a py there. If your colors disappear, that means you forgot the .py on it. And it says enter an even integer. 44, there's a nice one, and it prints it. Okay, that worked fine. Let's try and do it giving it an odd number. Now, if we watch what happens here, with the odd number, the expression will be false, and I will go inside the suite of the loop and print the error message, and then ask again. And it will keep asking as long as I give it odd numbers until finally I give it an even number and it says, okay, good. I'm happy with that. Notice the pattern here. We're checking for number in the Boolean expression. So before the while loop, I got a number. I did it by asking for input and then converting it to an int. And then at the bottom of the suite, I did the same thing again, got a new number. So within the suite, I did something, printed an error message. At the end of the suite, I got a new number. And that's a very standard pattern for a while loop. Now that while loop is just, oh, let's try one other thing here. We can, there's an else that we can have with a while loop, and the else is what is done when the while loop is completed. So what I did is I moved the print into the else, so now we'll go around the loop, and when we finally get an even number, the message at the end will be printed. So we can see how that, enter an even integer, I'll give it 11, and now I will give it an even integer. So it works just like it did before. There is no real advantage to having the else in this case, except that it does tie the final print directly into as part of the while loop. So one might argue that's a little more readable. Whether it is or not to you, that's your decision. We have another kind of loop, which is known as a for loop. And for loops frequently work on ranges of values. So let's take a look at range. If I say range 5, that gives me the numbers from 0 up to but not including 5. I can also do something like range from 3 to 10, which will do the numbers starting at 3 going up to but not including 10. So by default it will start at 0. It will always end up at 1 less than the number you specified. Why that is, well, it'll make sense as we go later on. So one thing I can do is I can go for count in the range of, say, 10. Yeah, let's not do 10. Let's do 8. I think that's what we did before with it. I can go print count. So now we're going to go through, we will print 0, 1, 2, 3, 4, 5, 6, 7, 8. Oops, sorry. We'll print 7 because we go up to but not including 8. Compare that to our while loop that we had earlier, which did the same thing, but we had a couple extra lines. With the while loop, we had to initialize the count beforehand, and we also had to add 1 to the count each time through. For loops a little bit cleaner, and we don't need to initialize before or have the value afterwards. So let's solve a little problem. What we'd like to do is find all the 3-digit numbers divisible by 11. So let's make this as a program, just like we did before. We'll get rid of our other program, and let's try this out. So we'd like to do numbers in the range 3-digit numbers. So that would be starting at 100, going up to 999. So that will be every possible 3-digit number. And if that number is divisible by 11, so we divide it by 11 and see if its remainder is 0, let's print the number. And we need to give this a title, div by 11. Again, always remember the .py. And let's run that guy. And we can see there's quite a few numbers that are divisible by 11. There's some easy ones. 121 is 11 times 11. They're probably, we can check. 880 is, that goes in there, what, 80 times. So we can see that it's working. We can also modify this a little bit. What if we wanted to count all the numbers? So every time I did a print, I could make my count one bigger. And at the very end, I could say print my count. Let's try that. So it goes through, generates all those numbers, and at the end, it prints how many there were. That wasn't very nice. Let's, there are count 3-digit numbers divisible by 11. Let's try that out. It runs through again, and we see our sentence is printed out there correctly. Notice that it's not on a separate line, so let's put another print in there just to make it look a little nicer. There we go. So there's 81 3-digit numbers divisible by 11. As before, if we wanted to, we could do this as an else. And I could take those two lines. I have to indent them into the suite. Now, when I get to the end, it'll just print those. Does exactly the same thing as before. Does this make it more readable? The print statement is now attached to the loop. Maybe that's a little more readable. So, in review, we have we've seen a while loop, we've seen a for loop. They're pretty much interchangeable. You can use a while loop, you can use a for loop. It's a matter of preference. As a hint for Python, I would encourage you to, what seems to work best is as we go through the language, we will see lots of iterators, which fit in nicely with fors. That'll be explained later on. But I've found a useful rule of thumb is use a for loop. Think about using a for loop first. If a for loop won't work, then think about using a while. Python, some languages it works the other way, but in Python, start with a for, think around fors. As we get further into the language, that'll make more sense. Try the for first. If that doesn't work, do a while. And there's our loops.